Lesson number 15, Titration and Standard Solutions. By the end of this lesson, you should be able to describe the procedure for carrying out simple acid-base titrations using a burette, pipette, and a suitable indicator. Finding the volumes of different solutions that react together and the concentrations of unknown solutions is called volumetric analysis. The experimental technique used is called a titration. This requires precise equipment, careful manipulation, and accurate measurement. Volumetric analysis is an extremely accurate way of analyzing solutions. Many different acids and alkalis are used in everyday life. These solutions are often analyzed using titrations. In these titrations, a pipette is used to accurately measure a set volume of the alkali into a conical flask. Pipettes come in several sizes varying from 1 cm³ to 50 cm³. Accuracy of plus or minus 0.05 cm³ is common. An indicator is added to the alkali in the conical flask. The acid is placed in a burette. This can measure the exact volume of the acid solution added during the titration with an accuracy of plus or minus 0.1 cm³. The acid in the burette is slowly added to the alkali in the conical flask until the indicator changes color. The volume of the acid solution added is then noted by reading the scale on the burette. For accurate results in volumetric analysis, we need to use solutions of an exact known concentration. These solutions must react completely with our solution of unknown concentration, be stable on storage, and have a sharp color change with the indicator. Solutions with these properties are called standard solutions. It is an important task of technicians in all analytical laboratories to make up these solutions. The steps involved in producing an accurate standard solution are as follows. Step 1. Calculate the mass of the solute required. Step 2. Weigh out the exact mass of solute using a balance. Step 3. Dissolve the solute in a small amount of water in a beaker. Step 4. Transfer the solution to a volumetric flask. Step 5. Wash the beaker with distilled water and transfer washings into the flask. Step 6. Add distilled water to the volumetric flask to make up the graduation mark. Step 7. Stopper the flask and invert 2 or 3 times to mix. Here's a worked example. Sodium carbonate, Na2CO3, makes an excellent standard solution for analyzing acids. What mass of sodium carbonate is needed to make up 250 cm³ of 0.2 moles per decimeter cubed solution? From the equation, the number of moles equals the concentration times the volume of solution. N equals 0.2 times 0.25. Here the volume has been converted into decimeters cubed. The moles of sodium carbonate needed is therefore 0.05 moles. The relative formula mass of sodium carbonate is 106 grams. So the mass required would equal the moles times the relative formula mass. In this case, 0.05 times 106, which means the mass of sodium carbonate needed is 5.3 grams.